Good morning, children. In this video, we are going to learn experiment number 2 of subject physics. The aim of experiment is to trace the path of the rays of light through a glass prism. Okay. Now, here we are going to learn how the refraction is taking place inside the prism. That means we are using a prism to study the refraction phenomena. Now children, do you remember in experiment number 1 we have used a glass slab to study the refraction of light. Okay, in the similar way we are using here a prism. Now the apparatus which are used to do this experiment, to perform this experiment is glass prism. You need a drawing board, you need a white sheet, you need drawing pins, pencil, scale, etc. Now what is the ray diagram of prism? Now, you already learn in the theory that prism is what? Prism is an optical medium. Okay? And it has 2 triangular surfaces and 3 rectangular surfaces. That 3 rectangular surfaces, it is also called as what? A lateral surface. Right? When these 2 lateral surfaces, if I see here, when these 2 lateral surfaces, this and this one, when they incline at one point, so it forms what? It makes an angle which is known as angle of prism. Okay, that is denoted by A. So angle of prism is always equals to what? 60 degree. Okay. Now when the incident beam, it will fall from any of a source. Okay, on a lateral surface, then this incident beam, when it enters into the prism, the beam will bend towards the normal. The beam will bend towards the normal. Now why it is happening like this? Why? Because the beam is going from a rarer medium and it is entering into a denser medium. So children, we know that whenever the beam enters from the rarer medium to the denser medium, the refraction phenomena take place and the beam will bend towards the normal. Now this refraction is taking place inside the prism, and when it strikes to another, that means opposite lateral face of the prism, the beam will emerge out from that prism, but in such a way that certain deviation takes place. Okay, the certain deviation is taking place between these 2 rays. Now how will you find out the angle of deviation? That means how much deviation take place. Okay, so to find out that angle of deviation, what to do? We have to extend this line. See, we have to extend this line, which is emergent beam, on backward direction, and we have to extend this incident beam in the forward direction. And when they meet at one point, then this angle we call as an angle of deviation. Okay, so this is about the ray diagram of the prism. Now what is the procedure? Now procedure is nothing but how will you perform this experiment. So in this experiment we need prism, pencil, eraser. See, these are the thumb pins that you are going to use in this experiment, scale. Okay. Now just like we have seen in the first experiment, which is based on a glass slab, we have used a glass slab, and through that glass slab we found a refraction of beam takes place. Okay. By using the prism also we are going to learn the same type of experiment through which we are getting that how the refraction will be taken through the prism. Okay. Now we have taken a prism. This is a paper sheet you need. Okay, white paper. You place this prism on the sheet of a paper and you just first mark the prism by using a pencil. Okay, we will mark a prism in this way using a pencil. So properly you have to make a mark of prism this way. Okay. Now you just remove the prism. I'll just join the corners here. Now what we'll do, we'll mark a perpendicular line, that means a normal. So I'm taking this point through which I'll draw a normal. I'll take this point, and by using a protector I'll mark a normal. Okay, so this is the 90. Okay, and since in the first I'm going to find out the refraction for the angle of incidence, which it should be 60 degree. So I'll mark the 60 degree angle also here. So this is 10, 20, 30, 40, 50, and this much is a 60 degree. Okay, so this is the 60 degree. So first I'll draw a normal. See, this is a normal. That means a 90 degree. It makes a 90 degree with that side of prism here. This is the normal. And where I have taken a point here, that is of 60 degree. So you have to just join these two points to mark an angle of incidence, which is equals to 60 degree. Okay. So this is what? This is angle of incidence. And this practical is, the first reading is for 60 degree I am taking. 60 degree. The angle of incidence is 60 degree. This is angle of incidence and this is incident ray. Okay. Now what we'll take two pins, because we have to show how the refraction it is taking place through the prism. We'll take two pins and I'll mark these two pins here on the incident ray. Okay. So in this way I'll just mark two pins here, okay, one behind the other, in one line, in one array. So this I have taken two pins. Now you have to just place this prism at the same position where you have already marked the prism, okay. So you have to keep this prism like this, and now you have to look from the prism, okay, see, through that prism you are getting the refraction, okay, through that prism you are getting the refraction, okay. Now in this way, through the prism you have to find out where you are getting the refraction, and align with that two pins only you have to mark the emergent ray. You have to mark the emergent. So you just mark two pins by using two pins the emergent ray, okay, in such a way that the four pins should be on one line. The four pins should be on one line. Okay. See, I am just placing these two pins one behind the other. Okay. It should be like both the pins they are in the same line. And through the prism, if you look now, all the four pins will be in. It will look like that all the four pins will be in one line. Okay. This way. Right. So all these are now in the same line. Okay. Now you just mark these two. You just mark these 2 points where you place that pins. So I mark here 1 point and I mark here also 1 point. Remove this prism and you just join these points, okay, in this way. See, okay. In this way you have to join it. Now this ray we called it as an emergent ray. This ray is called as an emergent ray. Emergent ray. Okay. And this one is what? Incident ray. This is incident ray. Now I remove these two pins also. And what I'll do here, I'll plot a perpendicular line that will act as a what? A normal here. Okay. So this is a line which is perpendicular line on this point, which is nothing but a normal. It is a normal. See, and this angle is known as angle of emergence. This angle is known as angle of emergence, and we'll measure that angle of emergence also. And you just join these 2 points. While joining these 2 points, it will give the angle of refraction. Okay, it will give the angle of refraction. See, this is what the angle of refraction are. Now see, this is the direction of the incident ray. If you see here, even though the pins, it will look along a one line, but here, because of refraction which is taking place inside the prism, the ray, it is bending, the direction of the ray, emergent ray, it is slightly deviated. Okay, so we'll find out the angle of deviation also. We'll find out the angle of deviation also. So to find out the angle of deviation, what we'll do, we'll extend this emergent ray in backward direction. Okay, this is our emergent ray. So we'll extend this emergent ray in backward direction in this way, and we'll extend this incident ray in the forward direction, because we know whenever we extend this incident ray in the forward direction, it will meet at certain point with the emergent ray. Okay, this one. So this angle which is forming between the emergent ray, because we have extended in backward direction, emergent ray, and incident we have extended in forward direction. So when it meet at this point, the angle which is forming here, that angle is known as angle of deviation, which is denoted by delta. So angle of deviation is denoted by delta. And now we'll find out the angle of emergence. We'll find out the angle of emergence by keeping this protector in such a way that this point, it should be exactly normal. Okay, so you keep this and the line like this, and then you just count from this 90. See, it is 10, 20, 30, 40, and it is 41. Okay, this much is 41. So I'll write down angle of emergence is equals to 41 degree. Okay. In the same way, we'll find out the angle of deviation. Now here again I'll keep the angle of for finding the angle of deviation. See, in this way, the perpendicular, I'll point this here, this line. Okay. So now again it should be properly arranged. So see, this is 10, 20, 30, 40. It is 41, 42. Yes, slightly it is nearly 42. Okay. So here delta means angle of deviation that we are getting is 42 degree. Okay. So here I will write down that angle of deviation is 42 degree, angle of emergence is equals to 41 degree that we are getting. And we know that angle of prism is equals to 60 degree. Okay. We can also derive the equation. We'll see whether the emergence, angle of deviation and angle of incidence that we have taken, it is correct or not. So we have the relation that angle of prism plus angle of deviation, it should be equals to angle of incidence and plus angle of
emerges. Okay. So this left hand side, what we will get, it should be approximately equals to right hand side, because we know while doing the practical there will be some errors. Okay. Now angle of prism is what? 60 degree we know. Angle of deviation that we are getting here is what? 42 degree. Okay. This will be equals to angle of incidence that we have taken again 60 degree, and plus angle of emergence that we got is what? 41 degree. Okay. If you see the left hand side and right hand side, approximately the values on both the side they are same. So that means whatever practical we did, we have verified, and the values that we are getting is correct. Okay. So in this way you have to do the experiment. Just I have taken one of the experiment based on what? I have taken angle of incidence is equals to 60 degree. We can see for 30 degree as well as for 45 degree. That
After the actual practical, the observation table that we have taken for 3 different readings. It is for angle of incidence, that is 30 degree. So I got angle of emergence, which is 60 degree, and angle of deviation that I found is 32 degree. Now these are what? The observed value experimentally. For 45 degree, when I have taken angle of incidence, it is found to be angle of emergence is 55 degree, and angle of deviation it is 39 degree. For angle of incidence 60 degree, that is shown in the actual experiment, the angle of emergence is 41 degree, and the angle of deviation it is 42 degree. Now the calculation part, here we are using that equation, and we know for angle of prism that is 60 degree. So for I is equals to 30 degree, see, we know the equation that angle of incidence plus angle of emergence is equals to angle of prism plus angle of deviation. What does it indicate? It indicates that left hand side, if it is approximately equals to the right hand side, then our experiment is successful. Okay. We know whenever we are performing certain experiment, there will be some errors while in measurement. Okay. So that we have to avoid it, that we have to neglect here. So this for first angle of incidence 30 degree, we get I plus E, that is 30 plus 60, that is equals to 90. And on right hand side we are getting 92, approximately they are same. For I is equals to 45 degree, again left hand side is 100 and right hand side is equals to 99. So again the approximately values on both the side they are nearly equal. For I is equals to 60 degree, again on left hand side when we have to add angle of incidence and angle of emergence, that is 101 degree, that will be equals to 102 degree. So in this way we have verified that on left hand side, means we have verified what? The result or the conclusion that we have taken is we found that the relation between the angle of incidence, the angle of emergence, and angle of prism and angle of deviation is satisfied. So we have satisfied the equation by this experiment.